So in risk calculation, I'm not going into the detail of the case control versus cohort study. We are just seeing the concept how to do this in JAMOV. Maybe when we'll conduct that epidemiological sessions on these type of study design, then we will elaborate more on the study design. Right now, we are restricting only to the basic concept of relative risk and odds ratio. So relative risk is basically, it is also known as the risk ratio or rate ratio. And alternatively, we call it as a relative rate. And it again measures the strength of association. It is usually done in an incidence study or the cohort study where you have a group of people and a comparison group and you divide them on the basis of exposure, like exposure versus no exposure of any risk factor, and then you follow them up for the development of a particular outcome. So you measure the risk of disease in exposed versus risk of disease in non-exposed, depending upon what exposure are you taking. So in which type of study design we relatively use this? So in cohort study, like I said, you start with the exposed and non-exposed group. And then as time passes, you compare like few people, they develop the disease in the exposed group and they develop the disease in the non-exposed. So there is no outcome of interest in the beginning of observation. But as we move ahead, then there are some observations. So we compare the incidence of outcome in these two groups of exposed and non-exposed. So this outcome status is established twice at least. So in the beginning also you measure the outcome to see that they are without the outcome, and then again after that end of the study also you measure the outcome or till the time that outcome develops. So basically, it can be this relative risk. It is basically measured in a type of prospective cohort study. You can do it in the retrospective cohort study, or it can have a combination of these two also. So these are few examples of prospective cohort study. So maybe this you can see that this is a classical example of a nurses health study when 1,17,000 nurses, they were followed up, and initially they had the risk factor. They were divided with the risk factor, and the risk factor was the obesity. So obese and lean, and then they followed up with the development. Outcome was compared, and the outcome was cancer or the cardiovascular disease. So at the baseline, there was a collection of baseline data. Then there was a follow-up period, and then there was a determination of the outcome status. This was a retrospective cohort study when it was done classically as an employee of tire manufacturer. So here, all those employees, they were divided on the basis. So don't confuse, this retrospective is not like a retrospective that case control. Here also you start with the exposure. So the exposure, like you have started with the exposure of this tire makers, rubber exposed. So the tire makers and the clerical staff, this was like exposure, tire maker, and did not have the factor was the clerical staff. And then they compared the incidence of death. So it requires much less time and the cost is much less than the prospective cohort study. And then again, the randomized control trial where you randomly assign treatment A and treatment B to the two group of people, and then you compare the incidence. So now what is the interpretation of relative risk? So if the value of relative risk is equal to 1, we call it as a no association. If it is more than 1, we call it as a positive association or risk. And if it is less than 1, we call it as a protective association. And how do we define relative risk reduction? So if you subtract 1 from this relative risk and multiply it by 100, it is known as the relative risk reduction depending on the sign. If the relative risk value is greater than the 1, then the participants in the exposed group are at increased risk of developing the disease. And if it is less than 1, the participants in the exposed group have a reduced risk of developing the disease. Now, what are the underlying assumptions for this relative risk? So the underlying assumptions are, first assumption is there should be one dichotomous variable, which is like nominal. It could be nominal or ordinal, and one dichotomous dependent variable. Assumption second is it should have an independence of observation. And assumption 3 is that the study design, we have talked about the study design. And here I have discussed all these cohort studies, so I'm just skipping. Now coming to the odds ratio is usually done in the case control study or analytical cross-sectional study. So the underlying assumptions of odds ratio is like, in this case, there is a one dichotomous dependent variable and one dichotomous independent variable. Just forgive us for this mistake, because here you can make one as an independent, and there is an independence of observation. And assumption 3 is that, again, it is usually done in an analytical type of cross-section study or a case control study. Like in this case, we select sample from population and we measure all variable only at once and at the same time point. This is example of analytical cross-sectional. And in a case control study, we have cases and we have equal number of controls, maybe, or you can have maybe 1:2, 1:3, or 1:4, depending on your requirement. And then you see the status of the risk factor, whether they were exposed or unexposed to a particular risk factor, and then you make the 2x2 table and classify it. So again, this odds ratio is, again, the odds of exposure is same. If it is 1, we say that there is risk is same in both. Rather, no risk is there, no association between the disease and risk factor. And if it is more than 1, we say that the odds of exposure among cases, it is greater than among control. And if it is less than 1, then we say that the odds of exposure in cases, it is less than among the controls. So now coming to the question. So for demonstration, I will demonstrate this odds ratio and relative risk. So if the first is the risk estimation is the odds ratio. So if you want to determine whether the smoking status has any association with the oxygen requirement at admission, and if it is associated with what amount of this association. So I have to do the odds ratio between smoking status and the oxygen requirement at the time of admission. So I'll go back to this data set. Again, the options are same. If you see, I'll go, this is the data. So I will go to this analyze. Again, this is the frequency. Here you can see it will be like contingency table only. But here you can see that this is the odds ratio and relative risk. So for odds ratio, maybe oxygen requirement versus smoking status. So smoking will be an independent. So I have done this smoker as a row, and this column is the oxygen requirement. So oxygen requirement, severity, oxygen 1. So this is oxygen 1. Uncheck this chi-square. Then you can click this odds ratio. You can click this row-wise percentages also, because in 2x2 table, you have to make the row-wise percentages. So here you can see the risk is 0.461. And if you see, just before you see the risk, and you have to see whether it is significant or not. But since it is crossing 1, it is not significant. This odds ratio with its 95% confidence interval. If you focus on this 2x2 table, can you see here that 31.1%. So this is the oxygen requirement, no and yes, and this is smoker, no. So if I focus on this, yes. So maybe if you see here, just a sec. So 17.2% of people who are smoker, they are requiring the oxygen, whereas the non-smoker, they are requiring more, like 31.1% of the people, they are requiring oxygen. So it's the other way around. That's why this odds ratio is the odds. So it tells you the reference category is the lower one. That means it tells you the odds of oxygen requirement in the smoker as compared to the non-smoker, because non-smoker has been taken as a 0 category. So it tells you the odds of oxygen requirement in smoker as compared to non-smoker. You can calculate also, like what will be the odds of oxygen requirement in case of a smoker. All of you please calculate what will be the odds of oxygen requirement in case of a smoker. Oxygen requirement 1 is yes and 0 is no. So all of you please write in the chat box. Odds of oxygen requirement in case of smoker, it will be 10 by 48. Can we take this 10? So it is the 10 by 48. Similarly, the odds of oxygen requirement in non-smoker will be 38 by 84. And if you take the ratio of these two values, it will come to 0.461. Okay, and this is the 95% confidence interval. Since it is crossing 1, you can say that this is not significant. Now coming to the relative risk. So in SPSS, both these values come together. But here you can choose an option of clicking either the odds ratio or the relative risk. So for relative risk, I started with the exposure status, and the exposure status was the steroid. So the person who was taking steroid at the time of admission, and then the outcome is the maybe what was the outcome, whether it was discharge or death. So in that case, what I'll do, I will shift this to, so this was the steroid. So in row, I'll move this steroid, and outcome I have moved here to the column. And again, you can see the status. So you can say the people who were taking steroid, 48% of the people died, whereas, 4.8%. Death was only 4.8%, whereas the people who were not taking steroids, it was 18.6%. And I have not clicked that relative risk. So this relative risk value is 0.855. So this relative risk is the relative risk of not requiring, getting discharge who were taking steroid. So this 0.855, and this was significant because it is not crossing 1. And you can calculate also with this 2 by 2 table, this relative risk and odds ratio. So the risk of death in case of person who is not taking steroid will be 22 divided by 118. And the risk of death in people who are taking steroid will be 3 by 62. So if you calculate this, it will come. And again, you have to see, in this case, it gives you with the higher category, this relative risk. So you can calculate this, and you can see this is a homework for all of you. So this 81.4 will be in the numerator and 95.2 will be in the denominator. And so this gives you the relative risk of death in people who were taking discharge. Okay.